Welcome back to our Math 171 video series. In this video, we'll talk about how to solve various equations. We'll begin with this example of a first power equation, 7x minus 15 equals 5x plus 13. I'm calling this a first power equation because all of the x terms that are in this equation are first power. There are no second power or higher power terms. For equations that are first power, we'll begin by moving all of the x terms to the left side. That means any x terms on the right will have to move. Likewise, we will move all non-x terms to the right side. That means any non-x terms, or constants, that are on the left will have to move. Let's have a look at our equation now. We want the x terms to be on the left. The 7x is already in the correct position because it's on the left. This means the 5x that's on the right will have to move. When you move that 5x, you will change its sign and it will become negative 5x. Now for our constants, on the right, where we want the constants to be, we already have positive 13. That one is okay as is. The negative 15 that is on the left, however, will have to move because we want our constants on the right. That negative 15 will change to positive 15. So now on our left side we have 7x minus 5x. On the right side we now have 13 plus 15. Now we will combine our terms. On the left, we say 7x minus 5x gives us 2x. On the right, we'll say 13 plus 15 equals 28. Once we're here, we will divide by whatever number is in front of the x. We will do this on both sides, so we will divide by 2 on the left and 2 on the right. On the left, 2x divided by 2 will cancel and give us just x. On the right, 28 divided by 2 will give us 14. This will be our solution to this linear equation. Here we have 2ab plus 2ac equals a plus square root 2 times bc. Although this looks much more complicated than our previous example, this is still only a linear equation because all of the instances of a, which we're trying to solve for, are first power. As with all linear equations, we'll look to our term of interest, that's the a, and we'll move all of the terms that contain a to the left side. After that, we will move all terms that do not contain a, even if they're not constants, to the right side. Now let's look at our equation and find terms that contain a. The first term, 2ab, does contain a. 2ac also contains a. And then we have a single a on the right side. And then square root 2bc does not contain a. Let's move all terms that contain a to the left side. 2ab is okay as is, we will not move it. 2ac is okay as is because it's on the left, we don't move that either. However, the single a on the right does have to move. When we move it across the equal sign, it will change to negative a. Therefore, on the left we now have 2ab plus 2ac minus a. On the right, we still have square root 2bc. Now notice we have a lot of different letters scattered around here, and so we cannot combine the 2ab with the 2ac. When you cannot combine any terms, what we'll do is factor out the letter we want. So our letter of interest here is a, and we will factor that out. We will place the a on the outside, have a new parentheses, and we will divide each of the terms by a. 2ab divided by a gives us 2b. 2ac divided by a gives us 2c. A divided by a cancels out and gives us the invisible 1. The right has not changed. It is still square root 2 BC. Now that we've factored out the letter we want, we divide by all of the stuff that's next to the letter. In the previous problem, when we did linear equations, we had a 2 next to our letter. Now instead we have a trinomial next to the letter, but we can still divide by it. Underneath the 2b plus 2c minus 1, we will divide by that entire trinomial. We will do the same thing on the right. The trinomials on the left will cancel out. On the right, they will not cancel out. In the end, we will have a equals square root 2 bc divided by 2b minus 2c minus 1. It's not a very pretty solution, but it's a perfectly acceptable one.